So hello everyone. So now today in this video lecture, I'm going to explain you guys NCERT book chapter. Uh, I think this is chapter number 3, and it says about the classification of elements and periodicity properties. So this is the PDF of the book, as you all know. So I'll be explaining each line of this book so that it will be easy for you to understand. So I think this is the best way to explain the NCERT book, because especially the CBSE people. So I think this is of importance to them. So classification of elements and periodicity in properties. First of all, what is meant by the name of the chapter? So we all know, like for now, we all know that what is periodic table and what are the various properties of certain elements, and we have ratified all the elements and with their atomic numbers and everything. So, but what is the story behind it, and how someone came to know about it? Like how the person who has made it, we'll be knowing about that person in this lecture. So how that person came to know, how he got the idea and of arranging the elements in such a way that there is some pattern, there is some periodicity in their properties. So let us start. So what are the objectives of this chapter? So what you are going to learn from this chapter is that, so after this study, so you will appreciate how the concept of grouping elements in accordance to their properties led to the development of periodic table. So for now, we already know that the periodic table is grouped in such a way that it has similar properties, and we will understand the periodic law, like which law it is based on, and we understand the significance of atomic number and electronic configuration on the basis of the periodic classification. Name the elements. Name the elements. Then we will classify elements into S, P, T, F block and learn their main characteristics. What are their characteristics? Like we will get to know, like since we have divided this whole periodic table into 4 parts, we all know that S block, P block, D block, and F block. So what are the main characteristics and why we have divided it into such blocks? And we will also recognize the periodic trends in physical and chemical properties of the elements and compare the reactivity of elements and correlate it with their occurrence in nature. Explain the relationship between ionization enthalpy and metallic characteristics. So we are basically going to study everything, like the trends in the ionization energy, how it goes from left to right when you go in the periodic table, when you go from up to down or down to up, what are the characteristic things that is changing, everything we are going to study. So all the physical chemical parameters we are going to study in this chapter. So it will be very, very helpful in order to understand the periodic table, and in this journey we will definitely memorize the periodic table as well. So first of all, the question we all should have in mind, and actually I think we all have the answers. Why do we need to classify elements? It is very simple. For example, if like you know that Cl, the halogens we all know, chlorine, chlorine, bromine, and all of those. So all of these elements, so you know that chlorine has 7 electrons in its valence shell, and similarly, all of the elements in that same group has 7 electrons in its valence shell. Okay, so the work has become quite easier for us. Like because of this classification of elements, periodic table is a bit simpler because it is not possible to memorize all the properties of 114 elements in the periodic table. So it's better that we have some classification, some periodicity and properties, so we all know that how important it is. So there was a need to classify elements into certain properties, and that is done by some great scientists. So how it is done and what are the various failed attempts, and all we are going to know in this chapter. So we all know, so in 1800 only 31 elements were known, but 1865 the डबल हो गया था, 63 एलिमेंट्स हो गए थे, बट अभी 114 एलिमेंट्स आर नोन, और कुछ कुछ एलिमेंट्स तो मैनमेड भी हैं, और अभी भी लोग नए नए एलिमेंट्स को बनाने की कोशिश कर रहे हैं। कुछ कुछ नेचुरली अकरिंग एलिमेंट्स हैं, काफी सारे नेचुरली अकरिंग एलिमेंट्स हैं, और कुछ कुछ हैंडमेड भी हैं, और अभी भी और भी बन रहा है। So to ease out the problem, there are so like it is very difficult to study the individually the chemistry for the elements, as I told you, like in order to study 114 elements and to know each and every properties of the all the elements, it's very difficult. It's kind of impossible. So it is better to group them and say them that these elements are similar to each other, and these another group which are similar to each other, which share some properties, like show similar properties, not same but similar. So it was very difficult for them because all the elements were that time elements were less also, but then also people thought that there will be more elements, and there is a need to classify them on some basis. So to ease out this problem, scientists search for a systematic way to organize their knowledge by classifying the elements. Not only that, it would rationalize known chemical facts about elements, but even predict new ones for undertaking further studies. So, what is meant by the last sentence? तुम्हें उन लोगों को पता था कि हम क्लासिफाई करेंगे तो क्या क्या बेनिफिट्स होंगी, क्लासिफाई करेंगे तो बेनिफिट्स ये तो होंगी ही कि केमिकल फैक्ट्स वगैरह जो है उस एलिमेंट्स के और उस ग्रुप के एलिमेंट्स के हमें ज्यादा पता चलेंगी, और अगर कुछ और एलिमेंट जो उस ग्रुप में आने चाहिए आ सकते हैं फ्यूचर में, उनका भी प्रॉपर्टीज हम लोग प्रेडिक्ट कर सकते हैं. So genesis of periodic classification. So this in this topic we will get to know all the things like कहाँ से स्टार्ट हुआ, पहले क्या डेवलपमेंट हुई, फिर क्या डेवलपमेंट हुई, फिर और कैसे पीरियोडिक टेबल बना. So classification of elements into groups and development of periodic law and periodic tables are the consequences of systematizing the knowledge gained by a number of scientists through their observations and experiments. तो पहले तो जितने भी एलिमेंट्स नोन थे सबके बारे में सारे का फिजिकल प्रॉपर्टीज, केमिकल प्रॉपर्टीज, ये सारे साइंटिस्ट ने स्टडी किया, और फिर जो एलिमेंट्स सेम ट्रेंड शो कर रहे हैं, सेम ट्रेंड इन द सेंस सिमिलर केमिकल प्रॉपर्टीज, सिमिलर फिजिकल प्रॉपर्टीज शो कर रहे हैं, उसको ग्रुप कर सकते हैं, है कि नहीं. सो एक जर्मन केमिस्ट थे जे डॉबनियर, वो ही सबसे पहले थे 1800 में टू कंसीडर द आइडिया ऑफ ट्रेंड्स अमंग प्रॉपर्टीज ऑफ एलिमेंट्स. जब साइंटिस्ट एलिमेंट्स के बारे में प्रॉपर्टीज को स्टडी कर रहे थे तो देखे कि किसी किसी एलिमेंट्स में ट्रेंड्स हैं. So by 1829, he noted a similarity among physical and chemical properties of several groups of 3 elements. तो उन्होंने ट्रायड्स बनाए. ये टेबल 3.1 में ये डोबेनर का टेबल दिया हुआ है. तो डोबेनर ने क्या किया, ट्रायड्स बनाया. तो यहाँ पर 3 ट्रायड्स हैं, तो एलिमेंट्स को तीन हिस्सों में बांट दिया. मतलब ये लिथियम, सोडियम, पोटेशियम, ये एक ट्रायड में आ गया. कैल्शियम, स्ट्रोंशियम, बैरियम एक में आ गया. क्लोराइड, ब्रोमाइड, आयोडाइड एक में किया. अभी ये एक ग्रुप में बांटने का उसके पीछे क्या रीजन था, और उसको बोला ट्रायड्स हैं ये. सो अभी ट्रायड्स का क्या है, इन ईच केस he noticed that the middle element of each triad had an atomic weight about halfway between the atomic weights of the other two. मतलब कि जो सोडियम का एटॉमिक वेट है वो लिथियम एंड पोटेशियम का एवरेज एटॉमिक वेट है. इन दोनों का एटॉमिक वेट को प्लस करके डिवाइडेड बाय 2 करोगे तो जो एटॉमिक वेट होता है वो सोडियम का एटॉमिक वेट होता है. मतलब 39 + 7 डिवाइडेड बाय 2 इक्वल्स टू 23. तो ऐसे ही इस वाले ट्रायड में भी है, इस ट्रायड में भी है, इस ट्रायड में भी है. ठीक है. And also the properties of the medial element was varying between those of the other two members. तो मतलब कि सिंपल है कि जो ये जो 3 एलिमेंट्स हैं, इसमें से जो बीच वाले हैं उनका तो एटॉमिक वेट भी दोनों के बीच का है, और इनका जो प्रॉपर्टीज है वो भी इन दोनों के बीच में कहीं लाई करता है. Since sorry Okay. So also, since Dobener's relationship referred to as law of triads. So law of triads क्या है ये आप लोगों को पता होनी चाहिए कि law of triads मतलब कि जो डोबेनर साइंटिस्ट थे उन्होंने ट्रायड्स बनाए, मतलब कि तीन तीन एलिमेंट्स का ग्रुप बनाया और बोला जो बीच वाला जो एलिमेंट है उसका एटॉमिक वेट भी उसके ऊपर और उसके नीचे मतलब कि बाकी जो एलिमेंट की बीच का है एवरेज है, और उसका जो प्रॉपर्टीज भी है वो भी उन दोनों के बीच में ही लाई कर रहा है। यही लॉ ऑफ ट्रायड्स है। मगर इसका ड्रॉबैक क्या था कि Dobener's relationship, which is known as law of triads, seemed to work only for few elements. It was dismissed as coincidence. तो उसको बोला गया कि क्योंकि सिर्फ और सिर्फ यहाँ पर 9 एलिमेंट्स के लिए ट्रायड का काम किया, मतलब कि 3 ट्रायड्स बना लिए उसने, तो बोला गया कि ये सिर्फ कुछ एलिमेंट्स के लिए ही वैलिड है और ये कोइंसिडेंस है, सो इसको डिसमिस कर दिया गया। तो ये पहला हो गया। अभी द नेक्स्ट reported attempt to classify element was made by a French geologist AEB D. Chantortius in 1862. अभी इसने क्या किया कि arrange the then known elements in order of increasing atomic weights and made a cylindrical table of elements to display the periodic recurrence of properties. This also did not attract much attention. तो इसने क्या किया बेसिकली, जितने भी एलिमेंट्स तब जाने जाते थे उन सबको एटॉमिक वेट में के हिसाब से इंक्रीजिंग एटॉमिक वेट से अरेंज कर दिया और सिलिंड्रिकल टेबल बनाया। वो इस बुक में कहीं मेंशन नहीं है फोटो, तो सिलिंड्रिकल टेबल बनाया और जो पीरियोडिक और उसमें दिखाया कि जो एलिमेंट्स है उसका कैसे पीरियोडिक डिफरेंस हो रहा है प्रॉपर्टीज का। नेक्स्ट क्या है, द इंग्लिश केमिस्ट जॉन अलेक्जेंडर न्यूलैंड्स in 1865 propounded the law of octaves. अभी law of octaves क्या होता है? अभी तो हम लोग law of triads पढ़े, अभी हम लोग law of octaves पढ़ेंगे। So basically, John Alexander Newlands ने law of octaves बनाया और he arranged the elements in increasing order of the atomic weights and noted that every 8th element had properties similar to the first element. मतलब कि हर आठवां अपने पहले जैसे फर्स्ट जैसा बिहेव करेगा, मतलब 1, 10, 16, 32 ये सबका सिमिलर प्रॉपर्टीज होगा। So the relationship was just like every 8th node that resembles the first in octaves of music. Newland's law of octaves seemed to be true only for elements of the calcium. Although his idea was not widely accepted at that time, he for his work was later awarded Davy Medal in 1887 by the Royal Society in London. तो उसने बेसिकली क्या किया, ये है न्यूलैंड्स का ऑक्टेव्स, न्यूलैंड्स वेरी फेमस ऑक्टेव्स। सो बेसिकली उसने क्या किया कि एलिमेंट्स को इंक्रीजिंग एटॉमिक वेट में अरेंज किया, जितने भी एलिमेंट्स का बोल थे उसको अरेंज किया और बोला कि हर 8th एलिमेंट का प्रॉपर्टी फर्स्ट एलिमेंट जैसा है, मतलब फर्स्ट 8th और उसके बाद 16th आएगा, 16th एलिमेंट। बट ये सही दिखाया उसने, मगर ये सिर्फ कैल्शियम तक ही वैलिड था, उसके बाद वो ट्रेंड फॉलो नहीं और उसके लिए उसको एक मेडल भी मिला है जिसका नाम है डेवी मेडल। The periodic law as we know it today owes its development to the Russian chemist Dmitry Mendeleev. So he was a very famous man. Mendeleev, we all know that periodic table is kind of, not the modern one, but the first periodic table was given by Mendeleev. And the German chemist Lothar Meyer. So there is another chemist, that is Lothar Meyer, who also has some contribution in the making of the periodic table. So they were working independently. They were not working in a group. So they were working independently in different places, and both were studying the periodic properties and were trying to make the periodic table. So both the chemists in 1869 proposed that on arranging elements in increasing order of their atomic weights, similarity appear in physical and chemical properties at regular intervals. So it is a broad statement to say. So when you arrange the elements in their increasing atomic weights, so you will get the physical and chemical properties similar at regular intervals. So Lothar Meyer plotted the physical properties such as atomic volume, melting point, and boiling point against atomic weight and obtained a periodically repeated pattern. Unlike Newlands, Lothar Meyer observed a change in length of that repeating pattern. Okay, by 1868, Lothar Meyer had developed a table of the element that closely resembles the modern periodic table. However, his work was not published until after the work of Dimitri Mendeleev, the scientist who is generally credited with the development of the modern periodic table. तो पहले actually Mendeleev, ये जो scientist है मेयर, इसने भी पीरियोडिक टेबल बनाया था जो कि काफी मैच करता है अभी के पीरियोडिक टेबल से, बट उसके पहले ही मेंडलीव ने पीरियोडिक टेबल बनाया क्योंकि उसका काम पब्लिश नहीं हुआ था, पहले मेंडलीव ने पब्लिश कर दिया, तो इसकी वजह से सब लोग मेंडलीव को ही जानते हैं. So while Dobenier initiated the study of the periodic relationship, it was Mendeleev who was responsible for publishing the periodic law for the first time. Okay, so this is very, very important. So we have started with Dobenier, and then we saw that what Dobenier coined was law of triads. Then we saw what Newland coined was law of octaves, and then we know that Lothar Meyer has also a lot of contribution and almost made the periodic table which looks similar to the modern periodic table. But before that, this guy Mendeleev, D. Mendeleev, proposed a periodic table which and is almost credited, like fully credited for the periodic table. So first started by Dobenier and Mendeleev, who is responsible for publishing the periodic law for the first time. So what is the periodic law? So it is very important question that every exam asks, and you must know the meaning of this. So what is periodic law? The properties of the elements are a periodic function of their atomic weight. So what does this mean? So this sentence has three different points to remember. So the properties of the elements, that the elemental properties we're talking about, physical properties and chemical properties both, are a periodic function. So means this is something to do with the periodicity, like recurrence of their atomic weights. Means if you arrange the elements in such a way of increasing atomic weights, then there is some periodicity in the properties of the element. Okay, got the point? What is the periodic law and what it actually states? What is the meaning of the periodic law? So this was Mendeleev who gave the periodic law. So Mendeleev arranged the elements in horizontal rows and vertical columns of the table in order of their increasing atomic weight in such a way that the elements with similar properties occupied the same vertical column or group. तो बेसिकली सारे एलिमेंट्स को इंक्रीजिंग एटॉमिक वेट में कर दिया, अरेंज और कॉलम्स बनाया और रोज बनाया और इस तरीके से एलिमेंट्स को प्लेस किया कि वो सारे की फिजिकल प्रॉपर्टीज वगैरह जो है और केमिकल प्रॉपर्टीज है वो सिमिलर हो. So Mendeleev's system of classifying element was more elaborate than that of Lothar Meyer's. He fully recognized the significance of periodicity and used broader range of physical and chemical properties to classify the elements. मतलब कि वो मेयर से better periodic बनाया. So in particular, Mendeleev relied on the similarities in the empirical formulas and properties of the compounds formed by the elements. He realized that some of the elements did not fit in with the scheme of classification if the order of the atomic weight was strictly followed. मतलब बेसिकली ये एक इम्पोर्टेंट पॉइंट है कि Mendeleev क्या चीज को रिलाई किया, अब सारे प्रॉपर्टीज को कंसीडर करके पीरियोडिक टेबल तब बनाना थोड़ा मुश्किल था, तो उसने क्या किया कि एम्पिरिकल फॉर्मूलाज, जैसे एम्पिरिकल फॉर्मूला मतलब कि कोई सॉल्ट हो गया जैसे NaCl, ठीक है, लिथियम क्लोराइड, KCl, तो ऐसे NaOH, KOH, LiOH, तो मतलब ये जितने भी उसके एम्पिरिकल फॉर्मूला है मतलब कि LiOX, तो x यहाँ पर 1 है, तो 1 उस सारे एलिमेंट्स के सारे एलिमेंट्स के लिए होगा, बेसिकली इसको एम्पिरिकल फॉर्मूला कहते हैं. तो वो सारे एलिमेंट्स जिनके एम्पिरिकल फॉर्मूला सिमिलर है और कुछ प्रॉपर्टीज ऑफ द कंपाउंड भी सिमिलर है, उसको उसने एक ग्रुप में रखा. सो ही रियलाइज्ड दैट सम ऑफ द एलिमेंट्स डिड नॉट फिट in with his scheme of classification if the order of the atomic weight was strictly followed. उसने कहा कि अगर उसने सोचा कि अगर एटॉमिक वेट को उसने देखा बेसिकली कि अगर एटॉमिक वेट वाले जो रूल है इंक्रीजिंग एटॉमिक वेट में अरेंज करना है उसको अगर स्ट्रिक्टली फॉलो करेंगे तो हर जगह हम लोग प्रॉपर्टीज को, सिमिलर प्रॉपर्टीज वाले एलिमेंट्स को साथ में ग्रुप नहीं कर पाएंगे। तो क्या किया उसने, he ignored the order of atomic weights, thinking that the atomic measurement might be incorrect, and placed the elements with similar properties together. इसने क्या किया कि atomic weight को उतना वेटेज नहीं दिया, और सोचना, उसने सोचा उस टाइम पे कि शायद एटॉमिक वेट का मेजरमेंट गलत रहा होगा, बट उसने फोकस किस पे किया, एटॉमिक वेट पे भी फोकस नहीं किया। मेन गोल उसका एटॉमिक वेट नहीं, उसका एटॉमिक प्रॉपर्टीज था, एलिमेंटल प्रॉपर्टीज था। तो एलिमेंटल प्रॉपर्टीज वाले को साथ में रख दिया, कुछ कुछ चीजें आगे पीछे की। फॉर एग्जांपल iodine with lower atomic weight than that of tellurium, that is group 6, was placed in group 7 along with fluorine, chlorine, bromine, because of similarities in properties. Okay. So at the same time, keeping this primary aim of arranging the elements of similar properties in the same group, he proposed that some of the elements were still undiscovered or उसके लिए छोड़ दिया spaces table. For example, both gallium and germanium were unknown at the time of Mendeleev published his periodic table, so he left spaces for gallium and germanium and named and these were under aluminum and a gap under silicon, and called these elements as Ika, aluminum and Ika silicon. Okay, मतलब एल्यूमिनियम के नीचे स्पेस छोड़ दिया, सिलिकॉन के नीचे स्पेस छोड़ दिया, बोला कि यहाँ पर एलिमेंट्स अभी फिट नहीं हो पा रहे, यहाँ पर एलिमेंट्स आगे डिस्कवर होंगे तो फिट हो जाए. So Mendeleev predicted not only the existence of gallium and germanium but also described some of their general physical properties. क्योंकि उसने जो ग्रुप को अरेंज किया था वो फिजिकल प्रॉपर्टीज के बेसिस पे किया, तो फिजिकल प्रॉपर्टीज के बेसिस पे किया, एलिमेंट प्रॉपर्टीज के बेसिस पे किया. इसका मतलब ये है कि जो और गैप्स भी छोड़े, मतलब कि उसने बस ये नहीं सोचा कि एल्यूमिनियम और सिलिकॉन के नीचे जर्मेनियम एंड गैलियम आएगा, उसने तो ये प्रेडिक्ट किया ही कि एलिमेंट्स नहीं है आएंगे. उसने ये भी बता दिया कि उसका फिजिकल प्रॉपर्टीज क्या होंगे, क्योंकि पीरियोडिक टेबल तो फिजिकल प्रॉपर्टीज के बेसिस पे ही अरेंज किया उसने. So these elements were discovered later, and some of the properties predicted by Mendeleev for these elements, those found experimentally, are listed in table 3.3. So this is a very great table you will see. So this was what he predicted, these two columns, and these two columns, and these two columns are what is found. So he predicted that aluminum के जो नीचे एलिमेंट है उसको एक का एल्यूमिनियम बोला और बोला इसका एटॉमिक वेट 68 होगा. जब मिला तो उसका एटॉमिक वेट 70 था. उसका बोला डेंसिटी 5.9 होगी और उसकी डेंसिटी कितनी हुई 5.94. बोला मेल्टिंग पॉइंट लो होगा, और मेल्टिंग पॉइंट के बारे में तो मैं एग्जैक्ट नहीं बता सकती हूँ क्योंकि वो कैरेक्टरिस्टिक फीचर होता है किसी भी एलिमेंट का, और बट गैलियम का मेल्टिंग पॉइंट थोड़ा कम ही था 302. बोला कि फॉर्मूला उसका ऑक्साइड का E2O3 फॉलो करेगा, और वो सच में Ga2O3 था, और क्लोराइड का फॉर्मूला ECl3 होगा, और उस टाइम पे GaCl3 हुआ. और सिमिलर ट्रेंड हम देखोगे कि सिलिकॉन और जर्मेनियम, जो एक का सिलिकॉन उसने प्रेडिक्ट किया था और जर्मेनियम जो उसे मिला उसका भी सिमिलरिटी है. So the boldness of Mendeleev's quantitative predictions and their eventual success made him and his periodic table famous. So we all know the periodic table by the name Mendeleev, right? Because he did some really great work by predicting the elements that were not found then, and also not just predicting the element but also predicting its chemical properties, physical properties, which is a big thing. So this is the very famous Mendeleev periodic table that was published earlier. So you can see there is some gaps, and you can also see that it is, the arrangements is not strictly on the basis of the atomic weights. Like there are quite a lot of gaps. So it is the old periodic table that Mendeleev made. You can see that tellurium has atomic weight of 127.6 and iodine has atomic weight of 126.9, but then also it is flipped. So what is the modern periodic law and the present form of the periodic table? So we need to know this also. So we must bear in mind that When Mendeleev developed his periodic table, chemists knew nothing about the internal structure of the atom. So basically, the subatomic particles were not known at that time. So he thereby showed that the atomic number is more fundamental properties of an element than its atomic mass. So there was a plot. So there was a guy known as Moseley. So in 1913, the English physicist Henry Moseley observed irregularities in the characteristic X-ray spectra of the element. A plot of root over mu against atomic number gave a straight line, and not the plot of root under mu versus atomic mass. So this suggested that atomic number is more fundamental property of an element than atomic mass. So, and we all know that the Mendeleev's periodic table was according to atomic mass, okay? And it was accordingly modified to modern periodic table, and this modern periodic table was basically arranged in the form of increasing atomic number rather than increasing atomic weight. So this is the modern periodic law, which you can also state as the revised version of the Mendeleev's periodic law. So the physical and the chemical properties of the elements are periodic functions of their atomic numbers instead of atomic weights. So the periodic law revealed important analogies among the 94 naturally occurring elements, neptunium and plutonium, like actinium and protoactinium, were also found in pitchblende and ore of uranium. It stimulated renewed interest in inorganic chemistry and has carried into the present with the creation of artificially produced short-lived elements. So you may recall that the atomic number is equal to the nuclear charge. So yes, whatever is the nuclear charge, Z, that is equal to the atomic number. So the number of protons or the number of electrons in a neutral atom is equal to the atomic number of that particular atom. So it is then easy to visualize the significance of quantum numbers and electronic configurations in periodicity of elements group. So when you arrange your elements in increasing atomic weight, so then you can realize that, so it is equal, since atomic number is directly kind of equal in numbers with the number of protons or number of electrons in the neutral atom. So it is more fundamental to group arrange it in the atomic number wise and not rather than the atomic weight wise. So it is, in fact, it is now recognized that the periodic law is essentially the consequence of the periodic variation in electronic configuration. So basically it is based on the electronic configurations, right? So which indeed determine the physical and the chemical properties of elements and their compounds. We all know that in element there are electrons, there are protons, there is neutrons. So these are the subatomic particles any element has, right? So all of these, if these elemental properties, like if you arrange your periodic table in such a way that it has similar electronic configuration, then definitely you're arranging it in a way that it has similar physical and chemical properties, because all these chemical and physical properties are basically governed by the number of electrons and number of protons and number of neutrons and all of these arrangements of electrons in the particular atom. So definitely, so arranging elements in the way of their increasing atomic number is more fundamental and more valuable. So numerous forms of periodic table have been devised from time to time, and some forms emphasizes chemical reactions and balance, whereas others stress the electronic configuration of elements. So a modern version, the so-called long form of the periodic table of the elements, which is given in figure 3.2, is the most convenient and widely used. So the horizontal rows, which Mendeleev's called series, are called periods, and the vertical columns are groups. We know this, right? So all of these are, like, when you go vertically, then all of these are called groups. When you go horizontally, then all of these are called periods. So this is the modern version, or we can say the long term of the periodic table, because this is what we all follow. So elements having similar outer electronic configuration in their atoms are arranged in vertical columns, referred to as groups or families. This is very important, like very, very important. As I was discussing, so all of these elements per se has similar electronic configuration, that is same number of valence electrons. So according to the recommendation of International Union of Pure and Applied Chemistry, which is abbreviated as IUPAC, so the groups are numbered from 1 to 18, replacing the older notation of 1A to 7A, 8, IB, all of these, and 0. So basically, this was the older version of naming the periodic table, but now the newer version is very simple and it is numbered as 1, 2, 3 to 8, 18. So these are altogether 7 periods and total 18 groups. The period number corresponds to the highest principal quantum number n of the elements in the number. So if you know the electronic configuration will be coming, that it is also written over here. So hydrogen and helium here, it will be hydrogen over here. So it is written over here. So it is hydrogen over here. So it is numbered 1 period. So it has the highest principal quantum number here is 1. For example, 5. So it has the highest principal quantum number is here 5 in this whole period. And all of these are arranged in such a way that it has same number of, per se, for this group 13, all of these elements has same number of electron, that is 3 in their valence shells. So you know this similarity, right? So the first period contains 2 elements. The subsequent periods consist of 8, 8, 18, 18, 32 elements respectively. The 7th period is incomplete and like the 6th period would have a theoretical maximum of 32 elements on the basis of quantum numbers. In this form of periodic table, 14 elements of both 6th and 7th period, that is the lanthanides and actinoids respectively, are placed in separate panels at the bottom. So in order to have 32 elements in the 6th and the 7th periods, so it is represented not in this table but in another table that we mean as lanthanoids and actinoids. So according to the quantum number, these groups should have 32 number of elements. So in order to fulfill that, it is placed somewhere else and not in the periodic table, but it is a part of periodic table for sure. So thank you for this lecture, and the rest of the part of this chapter will be taught in the next subsequent recordings.